so we got it muted for now. And
see, mute.
that's good. Okay, so we're going out. We don't need that test banner anymore. And let me actually, let's stop sending that out. So now, what I'll do is I'll make it so that it's, okay. So both of these are kind of in the picture, just so you're aware. So,
Okay.
yeah. I would just don't worry about the microphone.
Okay.
Don't worry about the cam.
Don't they always say that?
Just focus on the, just focus on the presentation. We got no audio going on yet. Thanks, everybody. Feel free to have pizza. That's why we're here, isn't it? Yeah, because your boss told you to be here. You're here because Deb said, right?
Yeah. Me too.
That's right.
Thought it would be a good idea. I did it twice this week.
Yeah. This pizza is so much better.
Yeah, it really is.
Really.
Where is this from?
What is it? DeFazio's, yeah. We were getting excellent salad too, but nobody was eating the salad with leftovers. So they stopped ordering. Jackie stopped ordering the salad. It was an awesome salad. But if you guys want to have us to resume getting that salad, what we can do is stop one of the pizzas and get the salad instead of salad's kind of expensive. It's awesome, but you pay for it. It's awesome.
It was good that one time when I was trapped in the meetings with you guys and we had nothing else to eat.
I mean, trapped in meetings.
Huh?
What do you mean trapped in meetings? Trapped.
It was like a door and it was closed. So I got scared.
Oh.
You grab me a napkin, please? I can get something penis stuck in my teeth just in time.
Yeah, right. Take my haircut.
Oh, thanks. I had it done yesterday. Audrey was like, I could just sit here for like hours with this razor and like thin your hair out because you have infinite hair. And I'm like, yeah, I know.
I'm gonna go live with the sound here.
Okay. Time for me to like, oh.
Patrick, fix your camera. All right, if started, right?
All right, the 6th.
I'm in my car. For those of you who are guests, I'm John Anderson. I'm the Director of Operations of Winslow IDEA, the Institute for Data Exploration and Application, and the Director of Web Science Operations for the TWC World, where you're in the bottom Florida. Welcome to our almost every week TWed series. Tonight, Katie Chastain, who's been our PhD student with us for some time, is going to give us a great talk on fun with spreadsheets. A couple of logistical notes. We are streaming live, so just keep that in mind for questions and that sort of thing. That your words are interred for posterity into the interwebs, the tubes of the interwebs. Soon we're going to start announcing our lightning talks, sign-ups for lightning talks at the end of the term. As you know, against for setting the agenda for the next talks. There is an opportunity. There's at least one potential opening for a TWed if you want to fit one in, although we've got a very tight schedule this term, which is really exciting. This is meant to be relatively informal. Katie's got slides that she wants to get through, but I'm sure she's open to your questions at any point. So feel free to ask questions. And with that, take it away, Katie.
Okay. Hi everyone, I'm Katie Chastain. I'm a PhD student here with Professor McGinnis. I think it summed it up best when Simon asked me last semester if I was a second or third year PhD, and I told him probably. But I've been working with a bunch of different sorts of codebook type applications and turning them into ontologies to help annotate data to make it easier to understand, search, and use. So this is sort of the format for my presentation. I'm going to discuss the sort of the motivation for why it's important to go over to take codebook specifications to turn them into ontologies. For a little bit of background, I'll talk about a bit of work I did with the semantic annotator several years ago, and then two more recent projects I've been a part of, the Jefferson Project and the Gates Foundation, Healthy Growth and Development, and then I will touch on future direction, which will hopefully start to be like my runway for my thesis. So for motivation, we get lots of data from every discipline in tabular format, in CSV files, comma separated values, in columns and rows and spreadsheets. And here in Titleless World, we like ontologies because they provide a controlled and very specific vocabulary, so that if we were talking about one particular concept, it has a unique identifier, and we know that every time we refer to it by that unique identifier, that it has a certain set of definitions and properties associated with it, and that it will be the same every time we refer to it that way. And so we want to translate data from tabular spreadsheets into our linked data format. And we also want to do this to help preserve more contextual metadata rather than just the data itself. I've got like an example spreadsheet sort of that John dropped in for me. That's basically you have the row that's that would be the subject of a triple in linked data format. The predicate, which would be the column header, usually would be like the measurement of something in some specific units, and then the object would be where those cross in the cell itself. And we can preserve contextual metadata from spreadsheets by encoding it in RDF by saying that every time we're talking about, say, a temperature in Celsius, we can label it with a specific URI, and we know that every time we use that URI, it is a temperature value in Celsius. So that makes it easier to understand one data set, and if you have it across multiple data sets, then you can be sure that it's the same thing in those data sets. And so that leads into the next one. It enhances interoperability. You can take data sets from different sources with semantic annotations or that are in semantic format, and it makes it a lot easier to compare them regardless of who took the measurements. And you can see when two data sets really are measuring the same thing. And it enables comparison across multiple sources of data. So it helps you find other data sets that look like what you want, and it also helps you compare them more easily. So I started work in the lab with the CSV to RDF for LOD, or the comma separated values to resource description framework for linked open data, which is a program made by Tim Lebo, who's a member of the lab. And that was mostly it was created in the interest of taking in these comma-separated value sheets and ingesting them and converting them into RDF for use in semantic applications, basically for visualizations. And it's available on GitHub. He has it up. It's still there. I used it 2 weeks ago. It works cool. And basically, it is for you specify your parameters for how you want to convert your tabular data, and then it will run the conversion according to those parameters. But that assumes that you have background ontologies that you already created, that you want to annotate your data with. And just sort of this is sort of a diagram of what we kind of do. You start out with these column headers, like a little timestamp. There are certain properties that you know about it that might like TFT in parentheses describing the column header, but we can make that machine readable. And then we convert it to XSD date time, and you can match that with anything else that is XSD date time in any other data sheet. And then you can pull out a measurement. The NH4 is ammonium, and micromoles, so annotating data in that manner. But for my friends from other departments, the little prefixes you see, the little UO, colon, XSD, colon, the CHEBI, colon, those are existing ontologies that we've annotated this data set with. So you'd be working with the assumption that someone else has already described the concepts that you want to talk about in your data set. And my work for the Jefferson Project, we had a sensor network that we wanted to align with the extensible observation ontology, or OBOE, or converting the data as it comes in. We want to know what each sensor measures and how. And I forgot to stick the OBOE measurement graphic here. I meant to do that. I forgot, apparently. My bad. But we got spreadsheets describing the, is that a tomato?
I've got one right here.
Oh, okay.
We're looking at it.
Okay. We got from the people running the Jefferson Project, these are domain scientists who study the ecology of the lake. They know what they're measuring with. They have these devices for performing the different water quality measurements, and YSI is the company that manufactured a bunch of them. And they had this spreadsheet that gives column headers names, essentially, and the parameter that's being measured and the units. So when a measurement comes out of one of these devices, the column header will have a number like 12, and you look in your user guide to find this sheet, and you see like, oh, okay, 12 means, I believe that is salinity in parts per trillion. And so we wanted to sort of remove the need for lookup and encode that in a way that it could be done alongside the data. And so I did an extension for the OBOE ontology, where OBOE describes measurements very well, and I aligned the these with the parameters that already existed in OBOE, and also to see which we already had and could reuse, and which needed to be added to describe fully the Jefferson Project data.
This is a list of variables.
Yes.
That would be in the individual spreadsheets that contain the data that the sensors were producing. What you're saying is this is a code book in the sense that it would be the column would be 12, for example.
Yeah.
For example, salinity rather than salinity.
Yeah. And I mean, if you're getting something that's pulling from like multiple sensors, you know, your column headers would be like 1, 2, 4, 8, 12, and that doesn't really tell you a whole lot looking at it. And so we want to match it up with the OBOE ontology so that we can describe everything, and we can get a bigger picture when you get this number out of the data loggers, what you're actually looking at. On the line on the top, I have 2 of the different flow measurements from the YSI spreadsheet. Further down the list, they have a bunch of different ways. They essentially had different column headers for measuring whether you're measuring flow in cubic meters per second or liters per second. And then on the other side, you can see I have OBOE characteristics, the volumetric rate, which is the characteristic is what you're measuring. And the OBOE standard is the unit of measurement that you're measuring it in. And since we have both of those pieces of information, we can annotate information. We know we can annotate the data in that way. And I had to add in the meter cube per second because that was one of, you know, there is a lot in the OBOE ontology, but not everything. And so I basically had to go through and hand curate and identify what needed to be added. And OBOE is mainly, I think it was originally used for water quality originally. So the coverage was fairly good for that, but the bottom example I have some things from weather. This is different sorts of sensors, but the code book that we had was soil_temp_C and so forth that's output by the weather sensor, and we had to generate a lot more classes for the weather specific data.
So all the blue stuff is stuff you ended up needing to add.
Yes, the blue ones are the ones that I added.
Separated out someplace because we should have that.
I mean, I have the OWL files there. They were with the others for the Jefferson project, the JP extensions.
I don't want, I don't think that we want to find a higher level concept.
Sure.
Mhm.
Don't use there to wait out.
Yeah.
But we can discuss it.
Lower level modules.
Mhm.
Yeah, I think, I think goes to just specify the concept and use it, and then I go.
Yeah, yeah.
I don't, that's kind of intention, that's why it's,
Mhm.
would be the act for me to see, those or other exchanges and they want to see what they are. So
Mhm.
I sort of that they decide not to do it.
Okay, we can take this. So, Katie, the difference between the two columns, like, for example, soil temperature,
Mhm.
and then, right on, is now over in the ontology column.
Mhm.
Soil temperature and then Celsius.
Mhm.
Again, I can see that the soil temperature is more specific,
Mhm.
than mass density, genus. Sorry.
Yeah, there's characteristics in this column and units in this column.
So in some cases, so like owl didn't have a notion of barometric pressure, because sort of that.
It had pressure. It didn't have barometric pressure specifically.
Oh,
So it had hectopascals, but it didn't have millimeter of mercury. So
okay, so there was another kind of pressure usage anticipated, so it was more, I refer to just pressure.
mhm. I added as a subclass essentially of pressure. There were a couple pieces where I added in, like with the soil temperature, we were also looking at air temperature and water temperature. So like for this particular application, it was important to have a separate characteristic for soil temperature.
Right, soil temperature, yeah, air temperature.
Mhm. Okay.
Good. So you don't have an example of the Jefferson Project data that you converted, do you?
Not that I could find easily after my computer died, but because I mean I was mostly working on the ontology side, so I have like the OWL files, but and I did this sort of essentially by hand in using Stanford's Protege. This is the like sort of a slightly expanded view of the Oboe core ontology with the very high level concepts. So you can see there's the characteristic, there's physical characteristic, basically everything I added as a subclass of physical characteristic because it's the thing we're measuring. And they also have units that are defined. They have this particular hierarchy that I had to learn and then basically hang off new classes as subclasses, like Christmas tree ornaments. And it was pretty easy to do. Protege is fairly, well, I don't know, it takes a little bit of getting used to, I think, but once you pick it up, then it's fairly handy for viewing and modifying ontologies, since it provides you this like these are entities, so you can click to expand the tree just to sort of see how the hierarchy is built, and it has a built-in reasoner, which if you're making assertions in your ontology and then you want to run the reasoner, you might you could see if there are any facts that come up that are reasoned rather than asserted that you're not expecting, which is a way to sort of help error check. It's free for download from Stanford. Let's see, for the HBGDKI ontology was for the Gates Foundation, the cumbersome acronyms used for healthy birth, growth, and development. They need an ontology to help explore and discuss a wide variety of studies to target interventions worldwide to basically help people around the world have healthier babies. We got some of the concepts for the original ontology through entity extraction from paper abstracts, and Jim talked about that a couple weeks ago with the entity linking tools when he talked about Linkipedia. And I was handed another spreadsheet with a set of sort of standard variable codes for some of their raw data sets. And those look like this, where you have, there's a set of these sheets, I think there were 25 of them, where they refer to different things. Like there's one, this is the subject level data, and there's others that refer to like the parents, the relatives. There's some for certain types of tests, but they're all in this format where you have a name, which is sort of like a terse label for a particular row, and then the label, which is the sort of expanded name, the entire thing of what you're talking about, and then error flag type length. I didn't really deal with as much, and then the comments, which provides some information. You can see some of them refer to certain code lists, so there are separate code. There's a separate code list file that had one table for each code list. It ranged from like the sex code list had 4 items. A yes/no code list that had yes and no, and that ranged up to, I think, the nutrition one for various nutritional testings, and the lab testing ones were closer to 200 different codes, but they were all sorted by their specific code, so there would be the ranged values for just these particular lines. And then you can also see, like, for case ID says for case control studies, so there's or the numbered sequentially from 1 to number of sites, so there's some other information too that's important to capture when converting this. Yeah. It looks a lot like yours. Yours has more columns.
Well, so when you say code list, equals sex.
Mm-hmm. Here's actually, this is an example of one of the code lists. This is the nutrition one, part of the nutrition one that I was talking about. So it's basically like you would fill in, if you're talking about aspartame, then they have aspartame there in that list, and it's just from a set of.
Okay. What parts you put there and what parts were already there?
This is as I received it.
Yeah, this is so both the set of variables
Mm-hmm.
and the codes are a characteristic of the essentially the database. It's a
Mm-hmm.
it's a master. This is documenting a master database that is an aggregation of 20-some, I think, studies. 27 studies. 20. These are 27 studies that were. Some of them were funded by IT specifically. Some of them are studies that have been brought in, and then what they've done is created it's kind of an exercise in master data management. They've all been brought in. The variables have been unified. So there's a set of variables. If you include both the more general codes as well as what you mentioned, so there's expanded total. There's some 20. There's some 1,000 variables.
1,015.
2,000 variables across all of the studies, and for some of them, obviously, they're numerical data, whereas others are classic database. There's a taxonomy of terms that get used. That's the code.
Okay. And so context, how many code books do you have?
How many separate code books?
Yeah.
I think there were 25 to 30 separate code books, or the code lists, because you can see here they have just one for sex, one for race, and one for feeding practice on this example here, and there were. That means that well, I guess like technically there's two things here for sex numeric and sex. Sex by itself is essentially for you would actually write in male, female, intersex, unknown, and then the code list has numbers where you would fill in a number that's there's a number for male, a number for female, a number for intersex, and a number for unknown. And so that's redundant, but some of them are like I know the nutrition ones and like the biological studies and the specimen tests are not. So.
Yeah, but you have people
Mm-hmm.
Each one you're talking about.
The one labeled sex for that one.
Well, you have both.
It's like yeah.
Where do we get values with this coded variable? Get it from sex, get it from race, get it from
So
yeah.
Only one thing that you sex, all one of them is sex.
The variable for sex appears in multiple of the sheets. So like this, like I said, this is the sheet for the subject level data. There's also one for like for pregnancy history, one for lab tests. There's 25 of different sheets, and the labels, the name, those things under name are unique on purpose, except where they're not on purpose. So study ID and subject ID were some of the ones that occurred in every single one, but we know that we were told that that was done on purpose, that it is meant to be the same study ID. It means the same thing regardless of which sheet you're looking at.
Anywhere where there's a controlled vocabulary, any variable that has a controlled set of words, of data values, has a code book associated with it, or a code sheet, really.
Yeah.
So this is the first time you're making control vocabulary. Yeah.
Well,
You just get,
the art book is basically controlled.
Yeah, that's,
Well, but you're talking about one control vocabulary for 26 code books?
no. Each variable has a controlled vocabulary of values that can be associated with it. This is not hard. Sex is male or female or undetermined.
So an else gets an enumerated.
Yeah.
And in this case, there's exactly four.
That's the cool part.
Mm-hmm.
So you let's take example. You have just sentences, male, no.
That's right. And that's the only value that can just have.
Okay, but why is there intersex that's different from
Correct.
Yes.
what happens in one group that male, and the other one intersex?
We don't have it. There's only one code.
We only have one code book in this case because the data manager has aligned a number of different data sets to the same basic schema. And so what our job is to align that schema with our pre-existing ontology.
So the study mentions the study has as a variable sex. I think they've expanded it both sex and sexing, right?
Yeah.
So any study has sex and both sex and sexing, and then the values come from the code book sex. And if there's you have one of the studies provides some value of sex, then it's important to observe that and you read in the code book.
Okay, I didn't know that they talk about a single vocabulary. Then, because if it was not, then you would have a lot of them.
Yeah, this was provided by Gates as this is how we wanted our data to look. We have decreed this is how the data looks. This is the vocabulary that we use essentially. So yeah, and so that's it. Yeah, that's a step because it's like, okay, we can be sure that anything we get from them uses these names for variables with those definitions. If we get something that says ARM CD, that's treatment ARM code every time, regardless of source, because they have theoretically already made all of their data fit this schema. So you don't have that convenience yet. Yeah.
No, right.
Not yet.
Well, somebody's done like a year's worth of manual work.
Yeah, this was nominally 27 studies, all with different sets of variables. And the exercise was one at a time, bring them into this master model. And
so here basically a lot more studies with no one specify a single vocabulary. Variables are added to everything.
well, this is why you get paid the big bucks.
No, I'm not.
So my understanding is that cheer is basically one step before this code book. We don't have this yet, but once we get it, then I can work my magic.
But it should be noted though, Katie, that we're fixated on this project called Cheer, which the internet viewers have no idea what they're talking about.
Child health exposure analysis for consequences.
But it is quite common in enterprise data sets, enterprise data models, or other kinds of things. You see this a lot in NASA, for example. To have a data dictionary, which is the set of variables, defines a set of variables and explains them. And for any variable that is coded, which has a controlled vocabulary, to specify and provide that set of terms. So this is a very common model for a wide range of applications.
All right. Let's see. Yeah, this is the one of the controlled vocabularies that we were talking about. The sort of enumerated type where these would fall in. These, like I said, I think these are from the nutrition tests, where they would perform a variety of tests, and each one would be noted with one of these for whichever one particular thing they're measuring. And I ended up using I went back to the CSV to RDF for LOD tool. This is a little bit different from, the original use for it. Originally we were using it to ingest completed data sets, but these are actually tables of metadata. It's, where somewhere someone has data that follows like these schemas, and we wanted to make ontology classes out of this so that, theoretically someone could then go do one of these and they would have the HBGD ontology in the little bubbles up here, so they would have the terms they needed here to annotate their data. So it was fairly easy to do. I mean, CSV to RDF for LOD, there's a learning curve to it, but I did it in about a day, I think. And to basically run through the file or the set of files and map them. So essentially, you see here, one of the rows was the case ID. It has a label that's the subject ID of the matched case, and it has a comment for case control studies. And down here at the bottom is some of the resulting RDF. This isn't completely correct, but it was sort of, this was done more or less automatically with some of my handling on the parameters in about a day. So it ran through and made classes. You see the ontology class is here, the hbgd.org/ns/case ID, and that would be your unique identifier for this case ID concept.
And everything's directly into that.
Yes. Yeah, we did some sort of massaging afterwards, but the sort of first stab at it was done through this software. And then we have the label is case ID. I think we went with definition, and then we like editorial note. So all of the information from this spreadsheet is preserved in the RDF. And we have, like for case control studies that's specified here alongside with unique identifiers, so we can all get to it at once. So for future direction, we've been hearing a lot about cheer. And I mean, I guess like we've done other medical applications here and Data One, pretty much anything with the codebook really. So cheer wants to, like we were discussing, have a bunch of data from disparate sources brought together. Ideally, I guess, with one schema, or at least with some way that everyone could use it all easily. And since it'd be people contributing data from multiple sources and looking to see who has data that they might be needing from someone else, searchability is important. And so we would need to have a good way to sort of build up the ontology behind that would allow us to annotate data sets. So it's sort of not data annotation, but it's how do we get the labels to annotate the data. Other things, more automated process. The Jefferson project portion I did pretty much by hand. I was going through OBOE, which is fortunately not a very large ontology, and just sort of seeing what's there, what's not. Spent a couple interesting days on the unusual units of measurement pages on Wikipedia a couple times to just sort of like nail down exact definitions. And there's also communication with the domain scientists there, where I was asking people who are used to working with the instruments, like what does it mean when it says this really? So if we can more automated process and sort of related to that, some sort of workflow or some sort of tools to sort of put in the hands of the domain scientists to sort of give them sort of a head start. Since they might not know the semantic web side of it as well, but they know, their best practices. They'll know this file has been on my computer for a year and a half. I know what this data means, and I can tell someone about it. Tell me where to put the definition, so that you can put it into the semantic language. So I think that would be interesting, I think. Integration with other techniques like free text entity extraction, which we sort of did a little bit in the Gates project. I wasn't really involved in the entity extraction half of that, but it seems interesting. And I guess it could be sort of a way to align something with existing ontologies if you could pull out from your column headers and maybe just sort of do an automated search somehow to try to match entities with what might already be available to sort of go through, to sort of streamline the go through OBOE with a fine-tooth comb sort of step.
And your data specification, it didn't have strings associated with the fields, or did it? Because, yeah, well, okay.
Sure.
They
Character,
were
yeah.
pretty short. Well, some of those comments,
Yeah.
well, those were pretty minimal. But some of them I thought actually had meaningful phrases.
Oh, for the comment section?
Yeah.
Yeah.
Commands doing entity extraction.
Yeah, that too.
Okay, sex and sex, they are names of this control vocabulary. And you're saying that code list equal to sex, this means whatever value is assigned is assigned from a list.
Yeah.
That's it.
Mm-hmm. So it really should only say it for the sex n, because sex is a character field with character field of length 8. So you would write there male, female, intersex, unknown. And then sex n is sort of essentially redundant, where you would have like 2, and that means you would look in the sex code book and that says female or whatever.
If you write it then, that's no longer code.
Yeah.
That's why there's two.
That's why there's 2 of them.
Yeah, but why did the second one is to the same code list?
Because I think essentially some data. So this is across many different data sets. So I think some of these, some of the data sets use race or sex, and some of them use sex as replacements.
And hopefully none of them use both sex and sex.
Yeah.
Okay, but what happens is that you have 2 classes, one class sex and another class sex on the RDF.
In the initial.
Yeah, the initial
value
class.
types.
So the thing that we're not showing here is that
They're not the same thing.
we went through the mapping process where actually reviewed the resulting classes and mapped them into the ontology that's within the tree.
Mm-hmm.
In the process, I actually moved the sex and race and things as classes with the expectation that those will be mappable to more functional classes.
Because like we already had.
What?
Why do we?
So only a couple of us.
Okay, I just started thinking already that it's something that has to be done, right?
Yeah, because it's not, this isn't that day they completely process.
Hopefully it will be by the time I graduate. I don't know, we'll see.
Okay, so I'm not doing the so you just made the idea. Why else to preserve the label, the comments?
Yeah.
The comments you cannot have any information on, provide more.
Yeah, it was just we started them as SCO's editorial note.
So, in a specific application, there's a very important, so for the HPDKI project, it's the ontologies actually use, the information in the ontology is actually used as kind of a searchable glossary. So, the definitions and the editorial notes and anything and other things also that are associated with them, not just on this class. These classes tend to be much smaller than some of the classes that have got in ontology. But those are actually rendered through this platform that Jim created, which was made visible by something called the ontology browser. So all of this would be shown in the, displayed to a user. So an ontology expert or the domain expert would be able to go in and they could actually search or they could just browse around and they could see the definition that variables that Katie's brought in based on data dictionary, those are also visible in the CD Ontology browser. You see these little snippets of definition. Some terms in the HTTPI ontology are much more robust. Not the ones based on variables, but the ones based on just in terms. Spent rules.
Going back to that list you have,
Which list?
the one that has the text.
This one.
Right. So this is a vocabulary, right?
Mhm.
Or the whole meaning.
Yeah.
Those are terms.
Yeah, these are what we want, like the
Okay.
these are with the labels.
We differentiate terms that are names of forms from terms that are names of forms.
We were treating them all as SIO attributes. They're all attributes.
So we have no. That style attribute is a class.
Mhm.
So every measurement we do is defined as an object. But in the process of now viewing, I found where you supposed to be in both choices. So the process, some of them are things like start typing,
That is the game that I use.
Mhm.
Yeah, and so that.
Are you moving that direction?
Yeah, it could be cool to do that, I think.
Can you give me an example right now?
Of how I could do that. I mean, I guess.
That is to differentiate from names that are names of the properties of a class, names that are from a class, and to group them according. If they are properties of a class, to group, to add the property to the class.
Okay.
Rather than just transforming everything in a class that basically says this is a class of everything that has this property.
What would be the basis of that? If you've got no information in it, it's hierarchy.
And I'm not even in hierarchy, I'm just fixing. If you could use the graph, that would be even better.
Because
Yeah.
So one of Apollo, kind of the reverse of what the saying, I think our question I asked at some point was, are these properties? Why aren't we just doing properties? Why are we doing classes? You could ask the same questions because every one of these is simply has a value as a. So why are these class? Why are these properties?
Okay. Then if you do not put them down, I do not see this very hierarchy. It's basically from format. I'm sorry, that I understand that level of fixes are moving forward, but I see the real good is to bring things to human level.
Well, yeah.
Because you have too many more properties.
Amen.
That's
not wrong. So, Papa, you're getting to what's this all about. It's why bother bringing all this? We're not converting data. That's amplifying data. Why would bother bringing all of your studies into the ontology? The reason is number one, so that it's included, so that it explains. So it's a research. So for every valid variable, there's an explanation of that variable is accessible. Two, if there's a description of if there's a result, okay, it says it's using this particular study. We simply mention the study. We know what data we use, what the variables we use. When this result is created, we know other results use those things. So there's a relationship that applied based on. So if you've got 80 data analysts creating results, using a variety of studies. How do we determine similarity? One of the ways we similarity is very easy. This is the way you search. That's I don't understand the question. That's not
This is like at the next level up.
What I'm saying is the analysts report the results. Okay. When they report their results, they mention specific data sets that they use. Okay. And they mention those, specify those data sets. Automatically, you know the variables in those data sets. But other scientists, with their results, they're also specifying those data studies, which have sets of variables. So having that information in linked format, we can find out immediately which results are somehow related, because these variables crossed over, even if nobody says this and this.
They use the same data set. And they might refer to the attribute within.
But they use the same variables. Yeah. So that's the point. They didn't necessarily use the same data set. This is variables. Some of those things, the data sets use those variables for this.
Well, and do we do it similar like when we said that sex are similar? Because they're different types.
Well, if we got rid of one of them. Yeah.
That can get into some documents.
Yeah.
As soon as he fixes that. Yeah.
Asking where.
No, but it's important to get to the why. Because so one different. We've been using tools. Two RDS transcripts time for converting data. What's novel about this approach is actually the description of the data, turning that into because it's all. It's much more powerful than using that as opposed to augmenting our intelligence.
We're at step one is the process. And so a lot of the challenges forward are collaborating some more sophisticated within the structure and linking existing classes with this sort of process. Right now we kind of got the pieces sitting around for
Correctly, that's one.
Yeah. I think so. We have
The question, going back on the report saying, I can
Fast
explanation.
This
I
one?
can already see it, it's just sitting on the table.
What can you say?
The explanation is already.
Yeah, but the spreadsheet is not in there. It's got to get put in there.
Well, and that's what she's doing.
Right.
But why you're not giving it up?
So here's one thing.
So that your tool can use it. What good is it in a spreadsheet? The ontology browser. Or what? It doesn't do any good. It's not being surfaced.
So one thing we built a concept from knowledge graph that has STX too. And those concepts are here to be applied to classes. Include every single one, even without class, you still have the ability to say, case study has been just 20 times in this article, or mortality is mentioned 3 times. That actually gives us about those items we wouldn't have otherwise. Once we get that, and we can look at differences in the similarities without any of the semantics other than add those concepts.
Okay, I really like this execution of the thought by showing the whole.
Yeah, so this is.
Should I pull up the ontology browser? Is that still up?
Well,
Oh, yeah, it's up.
Yeah.
I just found it earlier.
So what, like,
It's HPG,
look, there it is. Ta-da!
And we have, and for those of you online, this is where we
Yeah,
say goodbye. Thank you for watching.